Welcome to EPG Pathshala. Learners, today in this module we will discuss about the basic concepts of structural geology, and we will also discuss about the various linear and planar rock structures. Now let us come to the learning objectives. Discuss the concepts in structural geology, study relationship between structural geology and tectonics, examine the concept of dip and strike, describe societal benefits of studying structural geology, list linear and planar rock structures, get introduced to the elements of folds and faults, discuss criteria of recognition of folds and faults in the field, use of clinometer compass in measuring dip and strike will also be discussed. Lastly, we will classify the various forms of igneous rocks. To start with, let us look at some definitions. According to Billings 1990, structural geology is the study of the architecture of rocks insofar as it has resulted from deformation. Fawson 210 defined that structural geology deals with the geometry, distribution and formation of structures. Geological structures or rock structures, they incorporate symmetry and geometric configuration of rocks present in Earth's crust on all scales. Now, what are tectonic forces? Tectonic forces present in the Earth cause deformation, which are responsible for the formation of geological structures. Tectonics, it is the study of forces and motion that result in rock deformation and structures. These are the basic definitions which are used in the study of structural geology. Let us look at the relationship between structural geology and tectonics. As discussed earlier, structural geology is mainly concerned with the rock geometry, whereas tectonics deals with the forces and movements responsible for the generation of rock or geologic structure. Tectonics is quite closely connected to the underlying processes that cause geological structures to form. These structures provide information about the forces acting within the earth. The objective of structural geology is to determine and explain the architecture of rocks based on the field observations, which are also supported by laboratory investigations. Now, what are primary and secondary structures? Primary structures form as the result of processes connected with the deposition of sediments. So, they are also known as depositional structures such as bedding plane. Secondary structures, they are developed due to deformation or metamorphism. So, they are also known as deformational structures. What is outcrop? Outcrop is the exposure of the rock on the earth's surface. If the rocks are not exposed on the surface of the earth, they are referred as incrop. Here you can see in this photograph an outcrop of sandstone. Layering. Layering is developed in rocks due to deposition of sediments, rock materials or minerals. Bed. Bed is defined as individual layer or strata of sedimentary rock. Now, what is bedding plane? Bedding plane is a plane which separates adjacent bed. If individual layers are less than 1 centimeter thick, they are known as lamination. Stratification is the process of deposition of sediments in a layer by layer fashion. You can see beds, bedding plane and lamination in the line diagram given below. What is primary foliation? Layering which is developed simultaneously with the formation of volcanic rock. that is known as primary foliation. Here in the photograph you can see the layering which is developed due to the formation of volcanic rocks. Secondary foliation. Layers in metamorphic rocks developed as the result of development of new minerals and orientation of mineral particles from pre-existing rocks during process of metamorphism. In this photograph you can see secondary foliation which is parallel to the pen kept on the outcrop. Deformation is the term applied for the process in which original rock is modified. The original rock body is usually undeformed and it can be modified by folding, faulting, jointing or under the effect of gravity. There are three types of deformation that are mainly caused due to the horizontal movement of lithospheric plates relative to one another. Tensional forces, compressive forces and shearing forces. Initially, the deformation is elastic. When any body mass it undergoes deformation, initially the deformation is elastic, and on the withdrawal of stress, the body returns to its original form. The limiting stress is called elastic limit. The deformation is plastic when the stress exceeds the elastic limit, that is, body only partially returns to its original shape even if the stress is withdrawn. When there is stress continuously increasing, one or more fracture develops. The body eventually fails by rupture. You must have heard two commonly used terms by structural geologists: brittle deformation, ductile deformation. Brittle deformation relates to the fracturing of the rock. Ductile deformation indicates bending, stretching, folding, thinning of rocks and realigning of grains. Now we will discuss most commonly used terms in structural geology: dip and strike. Dip, it is defined as the inclination of bedding plane with respect to the horizontal. It is measured in the vertical plane lying at right angle to the strike of the bedding. Dip is a vector quantity as it has both direction and amount. Strike, it is the geographical direction of a line produced by intersection between inclined layers and horizontal plane. Strike is a scalar quantity because it has only direction and no magnitude. Strike of the bed is dependent on its amount of dip. Direction of dip, it is geographical direction along which bed has a maximum slope. Amount of dip, it is angle which varies from 0 to 90 degree according to the inclination of the bed. Amount of dip denotes the angle of bed inclination with respect to the horizontal. Now we will look at the relation between dip and strike. The direction of dip and strike of any inclined or tilted bed must lie at right angle to each other. This figure tells you about true and apparent dip. Now, what is true dip? True dip is maximum amount of inclination or slope of a bed along a line perpendicular to the strike in the maximum slope with respect to the horizontal. It is called true dip. Apparent dip. Apparent dip, the dip of the bed measured at any direction other than the true dip, is called apparent dip. The amount of apparent dip is always less than true dip. Amount of dip. It is the angle that varies from 0 to 90 degrees according to the inclination of the bed. Disposition of the bed can be horizontal, wherein angle of dip will be 0 degrees, that is no dip. Inclined or tilted, wherein angle of dip will vary between 0 to 90 degree. Vertical, wherein angle of dip will be 90 degree. The first line diagram gives you horizontal bed, second one is inclined bed, and the third one is the vertical bed. Now, how do you determine the attitude of beds with the help of a clinometer compass? Clinometer compass consists of compass and a clinometer. Compass has circular dial which is anti-clockwise graduated with 360 divisions at the outermost circle for reading the direction. The circle is called as azimuthal circle, wherein 0 or 360 represents for north, 90 represents east, 180 south and 270 west. Magnetic needle rests in north-south direction of the earth when it is set free. The desired direction is read from the dial with the help of N, that is north, marked at the end of this magnetic needle. One of the inner circle on the dial is also marked with the directions such as east, northeast, north-northeast and west, in supplement to the outermost circle to read the direction directly. Here you can see a line diagram of clinometer compass, and you can also see a photograph of clinometer compass. Now, let us learn about why do we study structural geology? What are the societal benefits of studying structural geology? It helps us in unraveling the mysteries of structurally complicated Earth's crust, planning mining activity, exploration, mapping and exploitation of Earth resources. It also helps in artificial groundwater recharge projects and rainwater harvesting techniques. It also is useful in selection of site for engineering projects. Then ancient civilizations, they flourished along the river valleys. The rivers usually flow along major geological structures. Rock structures can be broadly classified into planar structure and linear structure and folds and faults. Planar structures are those structures which are found on plane or as a surface of rocks. The major planar structures are bedding plane, metamorphic foliation. Metamorphic foliation is a planar structure which is formed during deformation and metamorphism of pre-existing rocks. Igneous foliation are observed in igneous rocks. They are also known as primary foliation, as we have discussed earlier. Fault plane is also a planar structure. It is a fracture along which rock blocks have been displaced. Joints, they are planar structures. They are regular or irregular in shape and they are found in the rocks. Joints are fractured surface along which the movement is negligible or not observable. The cooling of lava or magma can produce joints in the rocks. Here you can see a figure of a joint. Linear structures. There are mineral lineation. If the longer dimension of minerals are aligned in a particular direction, it gives rise to mineral lineation. Crenulation lineation are formed when any planar structure such as foliation is affected by folding on small or microscopic scale so that hinge line of these folds are aligned parallel to the direction. You can see this line diagram showing crenulation lineation. Siliconicides, they are lines like fractures developed on fault plane because of friction generated between two faulted blocks and usually show polished surface. Boudinage, pinch and swell and roddings. When the competent rock layers stretch and deform into segments, they are called as boudins. Individual boudins are commonly much longer in one dimension than the other two. Roddings describe elongated mineral aggregates. Folds are the combination of planar and linear structures. Folding can be defined as the bending of rock strata due to compressional forces acting tangentially or horizontally towards a common point or plane from opposite sides. Folding is common form of deformation and is more commonly found in layered rocks. Folds are best displayed by stratified formations. It can be sedimentary or volcanic or metamorphic rocks. Importance of folding. Folding exposes the deep-seated rocks on the surface of the earth. It increases the occurrence of mineral deposits because of the repetition of layers in a limited area. It facilitates development of site for deposition of mineral bearing solution. Folds serve as good host for oil and natural gas. Folding causes beautiful landscapes to develop, which may enhance geotourism. Now we will look at the various parts of fold. Wavelength of fold. It is defined as minimum distance between the two successive points of same phase. Axial surface of plane is defined by joining of fold hinge lines of successive beds. When the axial surface forms a plane, it is called as axial plane. Amplitude of fold is the length of perpendicular drawn from hinge point of the fold on a line joining the two inflection points of the fold. Hinge point is the maximum curvature on the profile section of the fold. You can see all these terms defined, they are shown in the line diagram. Fold axis, it is an imaginary line which by moving parallel to itself generates the fold. Inflection point is that point where the fold limb changes its attitude. This photograph shows a typical fold. Now, whatever terminologies we have discussed in the last slide, you can see in this fold. You can see both the limbs, you can see axial plane and hinge zone. Fault. Fault is also a linear structure. It can be defined as the fracture along which there is observable amount of dislocation or displacement of two rock blocks. In this photograph, you can see bed 1. Bed 1 is displaced along this red colored fault plane. The development of fault on the rock takes place due to tectonic stresses such as tensional, tangential or compressional or in the combination of both. Now, we shall discuss parts of fault. Fault line or fault trace. It is a line formed by intersection of a fault with the surface of the earth at given surface. Dip of fault plane is the angle of inclination of fault plane with respect to the horizontal. Strike of fault plane, it is the strike of that plane. Head of fault plane is the angle made by fault plane with respect to the vertical line. Fault zone, it is a zone of numerous small scale fractures. They constitute a fault. In this line diagram, you can see all the terms which have been defined. Now, what is fault surface or fault plane? It is a surface or plane along which dislocation takes place. Hanging wall, it is the rock mass resting above the inclined fault plane. It is also known as hanging wall. Whereas footwall is the rock mass resting below the inclined fault plane. Slip. Slip refers to any displacement parallel to the fault plane in the given direction. Dip slip, it is the movement parallel to the dip direction of the fault plane. Strike slip, it is the movement parallel to the strike of the fault plane. Oblique slip, it is the movement if both dip slip and strike slip movements are present. Heave is the horizontal component of dip slip. Throw is the vertical component of dip slip. Now, how do you recognize faults in the field? You get visible displacements of vein, dikes, strata in the field. You will also find slickened sides and fault breccia along the fault plane. You will also find the presence of crushing, shearing, pulverization of rocks, myelonites, silicification and mineralization along the fault plane. If sedimentary or metamorphic rock types are juxtaposed, a fault is indicated. A fault may be indicated. And if you find abrupt change in topography, it is indication of a fault. Abrupt change in the flow direction of the stream or a waterfall also indicates a fault. If you find the presence of springs along a line, it indicates fault. If you observe dragging of strata and there is some flexure of bending or bending of beds present along a plane, that may be a fault plane. Now, lastly, we come to the forms of igneous rocks. When the igneous body occur parallel to the bedding plane of the country rock, it is called as concordant body. Whereas, when igneous body cuts across the bedding plane of the country rock, it is known as discordant igneous body. Sill. In this line diagram, you see sill. It is a concordant igneous body which lies parallel to the bedding plane of the country rock. Whereas dike, it is a discordant igneous bodies with more or less tabular shape, and it exhibits a cross-cutting relationship with the country rock. Laccolith, it is more or less concordant intrusive dome-like mass of igneous rock which arches upward and has a more or less flat floor. You can see in the line diagram. Bismullith, it is a special type of laccolith with more or less vertical and cylindrical bodies that cut across, that is, they are discordant to the adjacent sediments and are bounded by steep faults. Lopolith, it is more or less saucer or basin shaped concordant igneous body which concaves upwards. Phacolith is a concavo-convex concordant igneous rock which occur along the crest and trough of the folds in the country rock. You can see faccolith in the line diagram. Conolith, it is irregular igneous intrusion whose form cannot be classified as laccolith, dike, sill or any other recognized body. Stock, it is an intrusive mass of smaller size than batholith and usually possess circular or elliptical cross section. And boss is the mass of plutonic igneous rock or stock that has circular outline on plan. Batholith is a huge plutonic igneous rock masses covering hundreds or thousands of square kilometers and occupy the core of the mountain, which you can see in this diagram. So learners, let us summarize what we have learned in this module. We learned the definition of structural geology. We learned the concepts of structural geology and introduction to basic terminology used in structural geology. We also discussed the relationship between structural geology and tectonics and concept of dip and strike. We also discussed societal benefits of studying structural geology. Linear and planar rock structures were also discussed. We also described various parts of folds and faults and their recognition in the field. Use of clinometer compass in measuring dip and strike was also described. And lastly, we discussed the various forms of igneous rocks present in the field. Thank you.